Thank you. Hi, everyone. The purpose of the session is to try to humbly demonstrate to you that somehow all the things you hear about the new technology and the future hype can bring some tangible value today. Okay, so effectively, when you look at the press, when you read, when you listen to the radio, when you're taking the specialized press, it's all about technologies. I tried to put some of those. I guess you could really cover the whole wall with all the hype that is going on around. And it's about what's the next big thing. But somehow, when you're an operational manager, when you come to your daily business, the big question is, what can I do out of this? So probably most of you know about the hype curve, but what is the typical reaction you have, and that I do personally have when I'm talking about all these new trends and all these new technologies? The question is, what's in it for me? What's in it for my business? What can I drive from this? And what I try to summarize here is a little bit of the different reactions that I'm perceiving when I'm engaging with my teams in the business. So typically, if you look at the very early stages about the research, okay, most of the operations persons tend to say, it's not for me. Okay, so I'm going to give you some examples, but something just, if you talk about synthetic biology, if you think about quantum computing, if you, all those things that you are hearing about, that you believe is for the next future, usually you say, okay, it's not for me, it's not for my business today. At the total opposite, at the really top of the hype, it's really about catching up. Okay, the fear of missing out. Okay, and I couldn't have such a speak on tech without mentioning Gen AI. Okay, so then, as of today is, okay, what's the big thing that I could be doing on Gen AI, okay, not to be a lagger? Should I confront my competition to move on? Okay, and bring that really to the mass market as fast as possible. So you see already two really quite violent extremes. If you look at a bit of those declining technologies, which we believe are declining as well, then my big question is, okay, should I invest? Should I not invest? Okay, I would mention 5G, I would mention metaverse, I would mention everything on platform engineering, which we believe are things that might come one day. But the question is, should I invest now? Will I get the return on investment? Should I go big? Should I go small? All those questions. And last but not least, if you look at the right-hand side, it's obviously, okay, going at scale. We all know about the connected worker, we all know about the IoT, we know about the edge computing, which I'm going to double-click on. But these are really the kind of natural perceptions and reactions that you would have as an operation manager when facing technologies. Then our ambition at Capgemini, okay, which is, for those of you not knowing us, a large French corporation of 250,000 persons on IT consulting, but also engineering. So what we want to do globally is really to move from this vision from tech to tech, or tech for tech, towards tech-driven business outcomes. Okay, and that's all about what we want to do here, is how do you derive a tangible value from those technologies that are making the headlines. So if I go and double-click a little bit, we chose to have a two-step approach. Step number one is about framing all this into what we call the mega trends, or the future of engineering, which are, from our understanding and our view, 5 key trends. The first one is the velocity of impact, because technology is going so fast that there is a big question about the acceptance about the society in general, about whether the technology is going too fast, okay, and how far will we adopt those technologies. If you look at the second, which we call organic engineering, it's all about injecting the sustainability aspect into engineering. Okay, every single product company, as we speak, is talking about quality, about cost, about time. Okay, but our belief is that these 3 pillars will be soon complemented by the sustainability portion of it. What's the impact of my product? Okay, is it on the water, on the biodiversity, on the carbon, all this? So, and this is a new product that is clearly ongoing. Beyond intelligence, you all know about AI. I won't go there, but I think we're just at the very early stages of unleashing the creativity, okay, much beyond what we thought would be possible. Obviously, I'm going fast just for the purpose of it. The fourth one, which is also an important topic, is really about the resource revolution, where, as we all know, at one stage, the design of the product and the way we're going to operate will be driven also by the availability of the resources. And last but not least, the digital fabric. Okay, I won't spend ages about digitization, all of us know about it. So the second step, okay, which I'm going to guide you through there, is how do we make this vision into something tangible for business leaders, for operational leaders, effectively having to use those technologies. Again, I won't spend ages on this, but just what's important is to really derive from those visions a list of technological assets that we believe are pervasive to many industry, or pervasive really to different countries, and bring those into tangible business outcomes. You call them business cases, you call them use cases per industry. And I'm going to double click on the mining a little bit later on. And at the end of the day, okay, we have really our closed loop with our customers, with our partners, to make sure that the promise that we're making with those is effectively delivering the tangible outcomes, okay, which will come to your P&L, which will come to your KPIs. And what we do ultimately, okay, and you will see on the LinkedIn, for instance, some of those that we're publicly showcasing, is really to make sure that for each of those 5 pillars that you saw before, okay, that we have really tangible proof of and data points. So if I now go for the purpose of today, is really, again, scratching the surface on some of those use cases that could be applicable for mining. And I chose 4 of those, okay, ranging from the very futuristic portions down to the very operational one. Starting with quantum computing, okay, which most people believe it's in 5-10 years down the road, but as you're going to see, it's actual. I couldn't have spoken about technology without mentioning generative AI, obviously. Going to the hydrogen as well, and the roaming on the edge, okay, which I believe as well is something that will change the game in the mining industry. So going to each of those. If you take at the quantum computing, one of the concrete applications I'm going to double click on, and just not to make any stress here or too much of a teasing, is for really the battery design, okay, which you would see is a big challenge. Everyone would like to see all the trucks, all the machines being electrified, okay, just to reach the net zero ambitions that we're saying. But obviously, when you go to the high payload, okay, the batteries as they are today, okay, are not sufficient, okay, to be really, to reach the rentability, okay, the financial rentability or the ROI to equip all this. So then the big question is, how do you change the game, okay, in terms of battery design, so that effectively this vision, okay, becomes a reality, okay, not only in 5 or 10 years, but tomorrow. And the way we've been searching with the highest end universities is really to go for the atomic modeling. Because the way you are doing the electrolysis, the way you are making all your, oil production depends on the design of batteries. And the sole way, as we speak, okay, that I believe about to make it happen is really to use quantum computing at the atomic level to really make that change. So as you can see, when you talk about quantum computing, okay, you can say it's 5 years, 10 years down the road, this is happening now. Okay. So our humble contribution to this, okay, we've been already designing algorithms that are working, AI algorithms that are using quantum computing. What do we get from this? Okay, so it's not that tangible and measurable yet because it's only in labs as we speak. Okay, but we have been demonstrating, okay, that we can iterate much faster in the design of the new batteries in much shorter cycles. Okay, so there are POCs that we're running with some gigafactories that we're making over there, okay, to effectively go from the lab to the fab, okay, in much shorter time frames. If I move on to generative AI, and I could have made a full speech around it, but I deliberately chose to take one very specific angle, which we're seeing not only in the mining industry, but in many engineering companies. It's how do you tackle the attrition you have for your best experts? Okay, so how do you make sure that all the documentation that you've been gathering over the last 20 years, okay, is effectively being used now that the persons who've been writing those have left. Okay, and how do you make sure that the younger generations are effectively taking advantage of all the capitalized knowledge or uncapitalized knowledge that you had to make it happen? And this is where generative AI is a massive opportunity to gather all this. Okay, because obviously it can browse thousands and thousands of documents that you've been storing without going to a complex knowledge management system that you would have gathered. This is a unique opportunity to bring all that knowledge together. Nevertheless, there's one drawback. I'm sorry, So Gen AI is one possible solution, but there are risks. Okay, there are risks. I won't spare you the whole details about the publicity, about really the risk of leakage that you might have. I would focus really on the bias that you would bring into your models. Because obviously, if you want the best of the breed of your engineering skills being gathered there, you don't want to get everything from the internet, okay, being brought in there that would completely bias the way you are shifting your technical documentation. Same wise, okay, you don't necessarily want a young engineer with 1 or 2 years experience being ranked the same way as your 25, 30 years chief engineer, okay, when it comes to effectively providing an accurate information. But if you take generative AI in a blunt way, all this will be put at the same level. So what we've been developing, okay, along with customers, is a consulting approach to first make sure that you're pre-ranking your internal information. Okay, so how do you make sure that you consciously decide what's going to be ranked or used at most by your algorithm, by your model, instead of just taking the mass of it without thinking about it? And then afterwards, it's a big question as well. Okay, depending on the size, which is the level of control that you want to get about your data and the way it's been modeled. Okay, and here there are plenty of alternatives. I could not elaborate in 30 seconds here. But do you want to go for public or semi-public models? Or do you want to build your own models? Okay, and that's clearly a trade-off, not only in terms of capitalization, in terms of risk, but also in terms of cost. Because people tend to undermine really what's the cost of the generative AI. Okay, because again, it's had the very high of the hype curve. But start having a look again at what it's costing you. Okay, for those of you making POCs, what is this costing you on a monthly basis? Okay, for your engineering capabilities. So one example we've been doing in the oil and gas industry was really about really building a technical documentation model. So based on large language models, really to reproduce technical documentation from simple sets of data to put a technical report in place. And what we do see is that obviously, okay, you all know this, that it's been reducing the production of a technical report from weeks to hours. Okay, no big surprise here. But what's interesting is that the 90% accuracy is ranked by our own customer. Okay, so which means that not only you're producing fast, but you're producing irrelevant information. Okay, and 90% is good enough, okay, just to really help you go at speed when it comes to engineering. Next topic, okay, and I'm just gonna accelerate a little bit, is about hydrogen. Okay, so everyone's talking about green hydrogen, blue hydrogen, XYZ hydrogen, but at the end of the day, it's the big question is it rentable? Okay, is it worth now going to hydrogen? Where, how, and how large? And that's the big question these days that we're facing with our customers is where and how to invest. What we do see, okay, and I'm going to take my engineering hat, is how do you trade off when you're thinking about hydrogen between the different constraints that you're going to get? Do you want to go environmental? Is it a safety? Is it an economical? Is it a people problem that you want to solve? And obviously, there are trade-offs to be made here that most companies are making on a very empiric basis, okay, not really mastering all the constraints that you would put in kind of a system engineering place or kind of a way. And also the sizing. Okay, so do you want to size big? Do you want to size small? So these are all the questions that we're seeing here. And you have to tackle this from the production, from the storage, and the usage perspective, all in all. So you see, the model that you're going to get out of that can be bloody complex. So what we've been doing here, okay, as a contribution to this, was really to design a system engineering-based approach to really put all those data together to make a conscious choice using pre-sizing models that we've been setting up in place to really help our customers move on to say what's the right decision to take when it comes to hydrogen. And just to give you one example that we had with our customers was a 20% improved yield across the complete supply chain, okay, from, again, the production, the storage, and the usage. I'm just speeding up. I won't spend ages, again, discussing about safety, okay, which is a #1 priority for most industries, especially, I mean, any industry per se. And what we do see here as well is that when you come to very complex environment, okay, where you have interaction, between automated vehicles, between workers, between, I mean, human-driven vehicles, all this kind of topic into a single concentrated place where a lot of unexpected events can arise, it's very complex to manage. And especially when it comes to highly critical environment, every single millisecond, okay, that you would spare into making a decision, okay, can have an impact on not only your people, but also your material. So when it comes to this, from a technological perspective, orchestration is key. How do you orchestrate all the information you have? How do you bring that all together into an AI model that will help you really correlate all this and help your AI models take a decision? Again, I could spend ages discussing about this distributed edge versus multi-access edge computing, but at the end of the day, from a technological standpoint, is just to make sure that you're correlating the events that you're getting from single sources that you would have on the field. And when you have a large mine, okay, obviously it's not something that you can log going to the cloud and coming back because you want this to happen real time, live. So what we've been building, and this was demonstrated 2 years ago at the Mobile World Congress, is a smart infrastructure platform, okay, that we've been using for smart road units, okay, in a very complex, crowded city environment, okay, that obviously we can apply to any environment, okay, where you would have pedestrian vehicles crossing each other. So this is live, this is working, and what we've been demonstrating over there, just one of the use cases is for each pedestrian, but you can take it for a connected worker, okay, to get real-time alerts, okay, in milliseconds when it comes to that. You can extend that, obviously, to any operations that you would have in your mind. You can extend that to any systems that would be fed by those data. And I could elaborate again and again on the use cases. So last but not least, because I'm pretty much there, I just wanted to give you, I mean, not so futuristic view of all those things could be combined together, okay, into something tangible. You can start with solar panels to create the energy and make sure that you're loading then, okay, your EV station, okay, for autonomous trucks to come, okay, by themselves. All this, okay, can already be managed over there. You can bring the hydrogen, okay, for much high payload vehicles also coming that route. But what's important is that for all the workers around, okay, who would be crossing the road of all those autonomous vehicles, of all the different vehicles and constraints that would come, is to make sure that you're putting this control tower that is really orchestrating, and again, I'm back to my previous point, which is really orchestrating all the safety criticality topics all together. All this is not futuristic. It can happen tomorrow. Okay, and therefore I'm inviting you to go just right next door and visit us to our booth, okay, where we can showcase in depth what those use cases are. Thank you.